It's time to show you how to configure Cisco IOS for public key authentication. I've created this simple topology with only one router and the cloud, which is in fact my Windows recording machine. There's also a layer 3 connectivity between the Windows, which will be the SSH client, and the router, which will be the SSH server. Let's test the layer 3 connectivity between Windows and the router. I am pinging the router. And it's working. Let's start with a basic SSH configuration. We'll enable SSH on the router. At this moment, SSH is not enabled on the router. We can see that port 22 is closed on the router and it's not possible to connect to the router using PuTTY and SSH. Let's see if port 22 is open. And I'm using the telnet command. Telnet, the IP address of the router, and the port 22. And we see that the connection failed, and that means that the port is closed. I'm opening a console connection to the router. The first step is to configure a hostname. I am entering the global configuration mode and I am executing the command hostname and a name. Let's say R1. Anyway, the hostname was already configured. But configuring a hostname is mandatory for enabling SSH. Good. The second step is to configure a domain name. IP domain name and any domain. Domain.com. Next, we'll enable the SSH daemon, which also means generating an RSA key pair on the router. Crypto key, generate RSA. Choose a key with a length of at least 2048 bits. If you go with the default, which is 512, it won't work. The client will not authenticate to this server with such a short key. So the key will have a length of 2048 bits. SSH enabled. And I enable SSH version 2. IP SSH version 2. Perfect. Now port 22 is open on the router. Let's check it again using the telnet command. And we notice that it has connected to the router. The next step is to configure the VTY lines to accept SSH and local authentication. Local authentication means that the users are defined locally on the device. It's not running a Radius or a TACAX server. So line VTY 0 and 4 transport input SSH. I can also allow telnet or not. If I add telnet, telnet will also be permitted on the device, and if I don't add telnet, I can connect only using SSH. Let's allow both SSH and telnet. And login local. Okay, that's all. I've enabled SSH on the router and the default authentication method is using the password. Let's try to connect to the router using SSH and PuTTY. I am opening PuTTY. The IP address of the router 10.1.1.10. The default port is 22, SSH and open. And it's working. There is already a user configured on the router, U1, and the password is Cisco. Perfect, it's working just fine. The next step is to enable public key authentication on the router, and that means to import the public key from our Windows or Linux operating system depending on what we are using. If we are using Windows and we've generated the keys on Windows, we'll open the public key file in a text editor. Let's open the public key we've just generated in the last lecture. This is the public key. I've generated the key with putty key generator, and I'm opening the file in Notepad++. This is the public key, and I will copy to the clipboard only the public key without the begin, comment, and end parts. So only the public key. This is the public key that I will copy to the clipboard. Copy. And I will paste it into the Cisco router. Back to the Cisco router, I'm writing. In global configuration mode, IP, SSH, pub key chain, this public key will be used by a specific user. In this example, let's say Windows user. So username, Windows user. Then key string and enter. Once I entered the key string command, I can keep adding lines until I type the exit command. In this case, I'll simply paste the contents of the clipboard, which is the public key, and paste. Perfect. I'm typing exit, exit again, and the last exit command. And I'm saving the configuration by executing do and write. Note that it's possible to add multiple public keys for a single user. This allows you to have multiple users access the router with the same username but with different key pairs. Okay, the configuration is done. Let's check if it works. I'll try to connect from Windows using putty to the Cisco router and see if it authenticates the client using the keys. Let's verify first that the router has the correct public key. We can print out the key fingerprint or hash using the following command. So from enable mode, I run show running config, pipe, a vertical bar, begin, pub key. Okay, this is the key fingerprint, and I'll verify if it's the same in putty key generator. I am opening putty key generator, and I am loading the private key. This is the private key, and this is its corresponding public key. Let's check the fingerprint or the hash. This is the key fingerprint. It's ending in 6CFF. And on the router, 6CFF. It's the same. By the way, this is a hexadecimal string. On the router, we have the correct key. If the key fingerprint or hash matches, we can continue. I'm closing putty key generator. So on Windows, I am opening putty and looking for connection, SSH, and authentication. Here, I'm clicking on the Browse button and select the private key used for authentication. Private key file for authentication. Browse, desktop, and the private key. And open. Now, on the main screen, I can save the session so that I will not lose the settings. I'll write here the IP address of the router, 10.1.1.10. The default port is 22 SSH, and I'll give this session a name. Let's say R1 Cisco. And save. I've saved the session. And open. It's asking for the username, Windows user, and I'm hitting enter. Great! We have successfully authenticated to the router using the SSH key pair. We see the message authenticating with public key and the key comment. It didn't ask for a password anymore. Okay, that's all. In the second part of this lecture, I'll show you how to configure the Cisco router for SSH public key authentication if the SSH client is a Linux machine. See you in a second.